Okay, going to record first. Is it recorded? Okay. So uncertainties in measurement. Okay, so this one will be the our class topics for today. Okay, so uncertainty of measurement value is the interval around that value such as any repetition of the measurement we produce a new result that lies within the interval. Okay, so every measurement that you take, every measurement in physics means that meter ruler, a beaker, a micrometer. Oh, okay. So uncertainties in measurement is um how does the value that you read from the measurement tools that is near, very near, or near to the real number. Okay, so let's say the point number 2, a length measured by a ruler normally can be recorded as 34.2 plus minus 0.1 centimeter. This means that the uncertainty of the length by a ruler is plus minus 0.1 centimeter, and the repetition of this measurement falls between 34.1 and 34.3 centimeter. So actually, if you can have, you see this diagram on the left, okay, what happened here is there are some difficulties of measurement when the, what you call this, scale, when the marks over here, this one, this mark on the left and this mark on the right, okay, what happened to my, okay, but the object was lies in between of the marks. This is uh it's a problem in physics. Okay, so either you have to change your measuring tools to much more sensitive measurement tools, or you can say that, or you can record that is under a uncertainties. Okay, so point number 3, similarly a length measured by a vernier calipers can be recorded as 4.20 plus minus 0.01 centimeter. So you can see that, okay, point number 2, by the ruler meter, you can see that it is 0.1 centimeter. Okay, so it is under the range of 0.1, 3.42, and is under range of 0.1, is either plus 0.1 or is minus 0.1 centimeter. Okay, but if you have a vernier calipers, okay, vernier calipers, the range is very, very small. 0 point. This is 1 decimal point, 1 decimal point, and this is 2 decimal point, right? So vernier calipers is very sensitive, okay, very sensitive measuring tools, and the errors that given if you use vernier calipers is very small. So either you have 4.19 centimeter or 4.21 centimeter. Okay, so you can see that if you have a measurement tools that is has a low sensitivity, the range of error is very big. You can see that this is 0.1 and to 0.3. If you have a very good or very high sensitivity measurement, you have 0.1 to 2.0.21. So it's very, very small, the difference of the what you call the range of the sensitivity, the range of the error. Okay, but you can see that every measuring tools, you cannot have like measure a length of table using vernier calipers, although vernier calipers is a very uh, sensitive tools. Okay, so you have to use a meter ruler, right? You cannot use a vernier calipers to measure a length of the table. Okay. Next, uncertainties measure. So why we why it's so important about the uncertainty? One is you can see the application, importance of uh, uncertainty is in LASIK eye surgery. So anyone here has done LASIK eye surgery in this class? Anyone here has done LASIK eye surgery? Who knows what is a LASIK eye surgery? Okay, seems that no one in the class. Okay, Zander, what is a LASIK eye surgery?
So I'm not so sure, but I have a rough idea of it.
Okay.
Like they use laser to remove something in your eye so that for your eyes to be, let's say your eyes got difficulty,
To
then
read.
it to be perfect.
Okay. Any more? That's actually a very good answer. Any more? Who knows what is LASIK eye surgery? Okay. I think the whole class left already, right? The classroom. Okay, LASIK eye surgery is a way to reshape. No, we are here. Okay, only Sito replied. Okay. LASIK eye surgery is a way to reshape the cornea of the eye. So to make sure the cornea is well, a little bit of a bulge, right? So it is using a laser to reshape it. And if you see is a laser, you can see that over here when the laser is used to reshape, you cannot have a big amount of error. So the laser cannot be over the cornea, left and to right. So the error must be very, very, very small. If not, they will be burn the eyes of the patient. Okay. One more is when you have a wrong estimation of uncertainty. Okay, this is what happened. A train was traveling too far from the end of the journey because we have 1,000 of meter and they didn't account the such of a slight uncertainty at the end of the track. So this is what happened. You can see that there is a train coming out from the window. Okay. Next, uncertainty in measurement. Okay, this is a table of common physics instrument such as a meter ruler. Okay, a meter ruler, the smallest scale division is 0.1 centimeter. So uncertainty is 0 plus minus 0.05. So if the marks like this for the meter ruler, this is mark number 1, this is mark number 2, and the object is lies between the two of the mark. So it will be plus minus 0.05 uncertainty, either is left or right. For vernier calipers, smaller scale division is 0.05 millimeter. Okay. And uncertainty will be 0.05 millimeter. Micrometer screw gauge, 0.01 millimeter. And also uncertainty is 0.01 millimeter. Analog stopwatch is 0.1 second and uncertainty is plus minus 0.1 second. Okay, so this is analog stopwatch. For digital stopwatch, it will be different. Thermometer, okay, is 1 degree Celsius and its uncertainty is plus minus 0.5 Celsius. For burette, okay, 0.1 centimeter cube, the smallest deviation. So uncertainty is plus minus 0.05 centimeter cube. Measuring cylinder, 1 centimeter cube. Okay. and uncertainty will be plus minus 0.5 centimeter cube. Voltmeter, the smallest scale division is 0.2 volt, and the uncertainty will be 0.1 volt. And ammeter is 0.1 ampere, and the smallest division is 0.1 ampere, and uncertainty will be plus minus 0.05 ampere. Okay, so the whole table over here you have to memorize because you're going to use it on your practical report. Okay, so all of this, how many instrument? 1, 2, 3, 4, 5, 6, 7, 8, 9. There will be 9 instruments that we're going to use in the future for the practical uh, conduct practical work and the report. So you have to memorize. You have to memorize the uncertainty for each instrument. Okay. Next, what is determination of uncertainties? Okay, we have physical quantities and we want to add the physical quantities. So when there is addition of two physical quantities, we normally estimate the uncertainty by adding the errors due to the two quantities. If x equals to p plus q, so p is a physical quantities and q is a physical quantities, and we need to add both of them. Okay, then the uncertainties of x, okay, equals to uncertainties of p plus uncertainty of q. For example, over here, we have a total current. We know that the total current that is I, okay, I equals to I1 plus I2. So there are two current that going through the junction, and we want to see how much is the total current. So let's say the I1. I1 is 3.50 plus minus 0.02 ampere. So let's say what kind of measurement tools is using, right? So we get back to the table, and it was using ammeter. Ammeter uncertainty is 0.05 and 0.1. Okay. So over here, it means that it was using another scale of the ammeter. Okay. So maybe it was using 0.0 smallest division, maybe 0.04. Okay. So the smallest scale and divide by 2, so you have 0.02. So it may be using a different scale of the ammeter, maybe a digital, who knows. Okay. And I2, the second current, 0.6.50 plus minus 0.02 ampere. So if you add up, you have 3.50 plus 6.50. This is the value, reading value. So you have 10.00. Okay. And for the uncertainty, 0.02 plus 0.02. So you have 0.04 as the uncertainties. Okay. One thing you have to remember, or two things you have to remember. One is here. How many significant figures over here? Nari?
3, sir.
3. Okay. How many significance over here?
2.
2. Is it 2 significant figures?
Same as 3, sir. 3.
3. First
Yes.
0 are not account. Okay. First 0 are not account. They are only counted after the point. Okay. So this is 3 significant figures, and this is 2 significant figures. Why we have this kind of 0.02? Okay. You see, these uncertainties, okay, have to align with the decimal point of the number. So let's say we have here, let's say you have a number like 43.555. Okay. So the uncertainties, it must be matched with the decimal point. So it will be like 0.002. So you can see that the decimal point over here must be matched with the numbers of the reading. It cannot be such as 42.555 with plus minus 0.1. You can see that this is 1 decimal point and this has 3 decimal point. So it follows the decimal point of the reading. Okay, can see that. Okay, any question on this one, this part? Okay, so the uncertainties must be following the reading, the decimal point of the reading. Okay, it does not follow this the standard figures, but it follows the decimal point. Okay, so such as this one, you can see that this is 2 decimal point and this is also 2 decimal point. Okay, how many scientific figures here? How many significant figures are here?
2.
Hmm?
2.
Scientific figures are 2. Why is it 2?
1.
1.
Why 1?
1, because only 1 here. Okay, so this is the complex things about scientific figures. You can put 1, you can put 2, you can put 3, and you got 4. Okay, you can check back with the notes of the uncertainty. Yeah, okay. So you can see that for this question, they have like this is 3 scientific figures, and this is 3 scientific figures. So answer should be 3 also scientific figures. So it was counted until this part as a significant figures. Okay. But it has a problem because it has 2 decimal points. So this one also has 2 decimal points. So you have to put back the 0. So this is a contradict of mathematics. Okay. Next, determination of uncertainties, subtraction of physical quantities. When there is a subtraction between 2 physical quantities, we normally estimate the uncertainty by adding the errors due to the 2 quantities. If x equals to p minus q, then change of x equals to the uncertainties of x equals to uncertainties of p plus uncertainties of q. Such as example, temperature increase. Okay. Change of temperature is the temperature final minus the initial temperature. If the final temperature that is 65.4, okay, plus minus 0.2, you can see that this is 1 decimal point and it follows the reading of the measurement that is 1 decimal point. This is 3 significant figures. 65.4 is 3 significant figures. This one, 25.2 is 3 significant figures, and the decimal point is 0.1. There is a decimal point is 1, and it follows the reading of the measurement. Okay. Then 65.4 minus 25, of course we have to get the value, and the part of the uncertainties will be plus, so 0.2 plus 0.1. So you have 40.2 plus minus 0.3. So you can see that this is 3 significant figures plus, 3 significant figures minus 3 significant figures. You have to get the value back in 3 significant figures with the uncertainty follows the how much is the decimal point of the reading. Okay, so this is how you do physics. Okay, you cannot just put out the numbers. You have to follow, you have to obey how much is the significant figures given by the question, and you have to write down with the correct figures. Such as if the question give one value with 4 significant figures, multiply with the a value of 2 significant figures. So the answer will be how many significant figures? Google? 4 significant figures. In the question, 4 significant figures times 2 significant figures. Answer will be how many significant figures? Google? There. I caught one. Let's try another name. Nicholas?
7, sir.
7?
7 significant figures.
7. Why not 8?
Uh,
Why you pick 7? Why not 8?
I think I miscount, teacher. Let me calculate again, teacher.
Okay. Sito?
2.
2. Wei Hen?
2, sir.
2. Xander?
2.
2. Okay. Cause sometimes I do want to check either the class is here, you are here or not. Okay. So the answer is 2 significant figures. Okay. 2 significant figures. Okay. Nicholas, is because you have to take the least as the answer. So it's a 4 times 2, you take 2 as the significant figures. You take the least. If you have, for example, 5 significant figures, and you operate, like say you plus with 3 significant figures, so answer will be also in 3 significant figures. You take the least, you cannot take the highest of the significant figures. So such as this one, you can see that this is 3 significant figures. This is 3 significant figures. You minus with the 3 significant figures, of course the answer will be in 3 significant figures. There are no list between the 3. There are no lower number than 3. So we take 3 as the significant figures. Are you okay with that, Nicholas? Do you understand?
Yes, teacher.
Okay. So they take the list. So they depend multiplication of physical quantities. Okay. So if we have quantities, let's say AX equals to A times B squared. Kogan, sir, my mic is not working properly, sir. Okay, you can use a chat to type. Okay, if X equals to A times B squared. Okay, so B is square. So remind yourself, B now is squared. B is squared. Okay, then change uncertainties of X. Okay, uncertainties of X divide uncertainty, the value of the X, actually the number, what is the number over here, uncertainties of A divide the value of A plus 2. Why you have to 2 over here? Because B is squared. So the B put in front, so the 2 put in front, so you have, actually is operation of the log actually before. Then you have this kind of formula. Okay, so school, if you have like, if you so 2 put in front, the change of B over B, the value of B. So if we have like X equals to A, B cube, so you have change of X divided by X equals to change of A over A plus 3 change of B over B. It's not change, it's I always use the term change, usually the uncertainty of X, uncertainty of A, uncertainty of B. So you number 3 put in front. Okay. In terms of certainty, we write as change of X equals to plus minus. Actually, this is plus minus. Change of A, uncertainties of A over A plus minus 2 uncertainties of B over B times with X. Okay. For example, here area of a rectangle. Okay. How many? We have 10 more minutes. Okay. Area of rectangle equal to length of times width, A equals LW. So you can see here, this is 3 centimeters, 3 centimeters, 1 decimal point, 1 decimal point follows. So then if you multiply, you have the number of the reading that is 1250 centimeter cube, centimeter squared. Okay, so you use back all these things put inside. So you want actually to get the value of uncertainties of A. Okay, so 1250, okay, you have to put over here, same like this one. This X, you put over here, there you have X over this part. Okay, so if you do the operation of this one, you get the A is plus minus 7.5 centimeter squared. Or we can use you can say that it is 8 centimeter squared. Why 8 centimeter? You can see that there is no decimal point, at the reading. So over here you have decimal point, right? So you have to round back to 8 to match up with the reading. So that's why you have plus minus 8 centimeter squared. Okay. See, this is for multiplication. For division of physical quantities, let's say y equals to c over d, then it's the same. Cities of y divided by c over c and change of d over d. So y over here, you put back on the other side. So over here, just because we want to find how much is the change of y, uncertainties of y. For example, density is mass over volume, rho equals to mass over volume. So if the mass is 80.0 with 0.2, the volume is 0.2 centimeter cube, centimeter per meter cube, per centimeter cube. Okay. So the number is, the reading will be 2.00. So this is 3 significant figures, this is 3 significant figures, this is 3 significant figures. So if you do everything, okay, you put out these two over this part, and the mass is over here with uncertainty 0.2 on the top, okay, and this one for the volume over here, and the number of the volume on 40.0 there. Okay, so uncertainty of the change of the rho, or uncertainty of the density, it will be 0.015. Okay, because this one already gone here. So it will be plus minus 0.0 gram per meter cube. Okay, so you can see that 0.15 is changed into 0.2, 0.0, sorry, 0.015, change round out into 0.02. Okay, to make sure it match with the reading that is 2 decimal point, and here also you have 2 decimal point. Okay, gram per meter cube. Okay, any question before I give you exercise in the WhatsApp? Any question you want?
No, sir.
No, sir.
No. Okay.
No, sir.
So everyone is clear. Okay. When you do the calculation for uncertainties, you not only getting you getting the answer for it, you have to also obey the rules of the significance and the decimal point. Okay, that's important when you do the uncertainties working. Okay. So how many minutes we have left? We have 4 minutes. Okay. So I think if you see that there are no question, so I think we can stop here. Okay, see you on, where is it? Oh, next week. Okay, see you on next week. But in meanwhile, I'll give you some question on uncertainties. Okay.
Okay, sir. Thank you.
Okay.
Yes, sir.
So
Alright,
see
sir.
you next
Thank
week.
you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you,
Thank you.
sir.
Thank you, sir.
Okay.